All right, let's talk about congruent polygons. And we remember that two geometric figures are congruent if and only if a rigid motion or a composition of rigid motions maps one of the figures onto the other to completely cover it. So what does that mean to us? Well, we're going to start with talking about the corresponding parts. So corresponding means goes together. So a rigid motion will map each part of a figure to the corresponding parts of its image, because rigid motions preserve length and angle measure. Corresponding parts of congruent figures are congruent. In congruent polygons, this means that the corresponding sides and the corresponding angles are congruent. So what we're doing is we're matching up like with like. So let's look at what this means. So triangle DEF is the image of triangle ABC after we did some rigid motions. So let's name all the corresponding parts. Let's start with the corresponding angles. So here we can see that angle A is congruent to angle D. So they are corresponding. They are the same measure. Angle B with 3 and angle E with 3 are congruent. So angle B is congruent to angle E, and then angle C and angle F go together. Now let's talk some corresponding sides. All right, so side AB with 2 is going to be congruent to side DE with 2. BC is congruent to EF. And then AC is congruent to DF because that's all we have left, and they each have 3 tick marks, so we can clearly see that's the case. So we go right down the line, 1, 2, 3, 1, 2, 3. The name of the triangle matches up the like parts to the like parts. So let's look at a congruent statement. So the way that we do a congruent statement, the way you want to do a congruent statement, is you want to name the first figure. So remember, we can go in any direction and start anywhere on the figure. So let's start at point P and go counterclockwise. So let's go this way and start with triangle PNM. And we could call it triangle MNP, triangle PMN, triangle NMP. Doesn't matter, it's the same triangle. But when we're matching up congruent figures, we got to match up like with like. So angle P is our 1. Angle Z is our 1. So try the triangle that's congruent to triangle PNM is going to start with Z. Then for P and M, we went upside 2, downside 1. So we're going to go upside 2, downside 1. So it's Z, X, Y. Now, had we done it this way, triangle PMN, and then just randomly named our second triangle, let's call it YZX. Well, P and Y don't go together. So this is not true. Don't do it this way. Name the first figure and then match the second figure to it so that whatever angle's in position 1, its congruent angle is in position 2. Whatever angle's in position 3, its congruent is in position 2. All the way down the figure, however many sides there are. So let's do another example. And let's start with triangle LJK is congruent. So pause the video here, name the corresponding triangle, the corresponding parts, and then restart and see how you did. All right, so we have triangle LJK, and we want to match it up. And so we're going to do, it's going to match up the triangle RTS. So the corresponding angles are angle L is congruent to angle R. Let's change color for this. So position 1, angle J is congruent to angle T. 2, angle K is congruent to angle S. 3. So now let's name the corresponding sides. And to do that, we're going to start and do the first side. So LJ is congruent to side RT. Then we're going to go 2 and 3. 2 and 3. So side JK is congruent to side TS. And we're going to continue like that all the way down the figure until we get to the very end, and then we're going to do first and last. So side LK is congruent to side RS. And that's the way we do congruent statements. That's the way we match up the corresponding parts of congruent figures. So let's use that information, and find out some more stuff. So in the diagram, DEFG is congruent to SPQR. So we got 1, 2, 3, 4. 1, 2, 3, 4. We know what goes together. Let's find the value of X. So here's our X. And X is going to represent QR. So what matches QR? But FG. FG is down here and it's 12 feet. So we know that 2x minus 4 equals 12. Then we're just going to do some handy-dandy algebra and find out that x equals 8. Okay, so now we got to find our y. Y is right here. And we'll notice that little circle. So it's an angle, and that's going to be angle Q right here. Angle Q goes with angle F, and angle F is 68 degrees. So 6y plus x equals 68. Well, we know x equals 8, so we'll plug that in. And then we'll just do our algebra. And y equals 10. So this is how the corresponding parts of congruent figures helps us. In fact, you go ahead and pause the video, do this one, and then we'll work it out together and we'll see how you did. All right, so let's find our x. Our x is right here, and that's going to be QM. QM goes with DE. DE is right here. So x minus 2 equals 8. So x equals 10. Not too shabby. Let's find our y. Well, here's our y, 3x plus 2y degrees, and that's angle P. Angle P is here. So it matches with angle G, and G is 84 degrees. So 3x plus 2y equals 84. X is 10. So we can substitute in the 10. And then we just go ahead and solve like we always do, algebraing it out. So 2y equals 54. Y equals 27. How'd you do? Great. So now let's move on and add a new little wrinkle in. Well, we know all about these properties because they're the same properties we've done before. So we're just going to apply them to triangles. The reflexive property for any triangle ABC. Triangle ABC is congruent to triangle ABC. The symmetric property, if triangle ABC is congruent to DEF, then triangle DEF is congruent to ABC. And then our world famous, much loved transitive property, if triangle ABC is congruent to DEF and DEF is congruent to JKL, then we can skip the middleman and go right to triangle ABC is congruent to triangle JKL. Who knows? This could come into play down the road. Let's find out. All right, so here we're going to divide a wall into orange and blue sections. Must be because we're Denver Bronco fans. Will the sections of the wall be the same size and shape? Well, I don't know. Let's find out. So right now we know we need 4 sides to be congruent to 4 sides. And we need them all to match up. Well, AJ is congruent to side CK, and oops, I don't want to write it that way. And DK is congruent to side JB, and side AD is congruent to side BC. It's given. Okay. We know that angle A, angle D, angle B, and angle C are right angles. Because that is given. We know that angle A is congruent to angle D, which is congruent to angle B, which is congruent to angle C because of the right angle congruence theorem. Which tells us that all right angles are congruent to all other right angles. So we've got that far. So we've got three sides. We have two sets of angles. We need two other angles. Well, how can we get there? Well, I'm noticing that side AB is parallel to side CD. How do I know that? Because they are lines perpendicular to a transversal, which we all remember that two lines perpendicular to the same transversal have to be parallel. That's what that is. So we got parallel lines. In fact, let's go ahead and mark this, that we have parallel lines, so we remember all right. Well, we also have JK here going through the center-ish of these lines. And we know we have parallel lines and we have a transversal in JK. So when we have parallel lines cut by a transversal, we immediately start looking to see if we have corresponding angles, alternate interior, alternate exterior angles, or consecutive interior angles. And here we actually know that we have alternate interior angles. So angle 2 is congruent to angle 3 because of alternate interior angles. And we can also see that 1 and 4 angle 1 is congruent to angle 4 by alternate interior angles. So we've got A, J, K, D is congruent to, so we went AJ down the middle, down the long side. So we got to go short, up the middle, down the long, CK, JB, because corresponding parts of congruent polygons are congruent. Four congruent sides, four congruent angles. We line them all up, and we have congruent wall sections. We use the same amount of blue paint as we do orange paint. Good for you, Denver Broncos fans. All right. Same exact example again. Almost. Oh, I skipped a piece up here. I missed that JK is congruent to JK because of the reflexive property. So, jumped the gun a little bit earlier. Don't want to do that. So here in part 2, we're going to do green and yellow. So are the sections going to be the same size and shape? Well, we know AB is congruent to CD. AD is congruent to BC. That's given. AD is parallel to BC. Also given. Angle A is congruent to angle C. And angle ABD is congruent to angle CDB, all given pieces of information. Well, we're given two angles, two sides. We need the third side and the third angle. Well, the side that they share is side BD is congruent to side DB. Once again, our reflexive property, because BD is the same and it's going to be the same length in both triangles. And then we have parallel lines, so we're looking for our corresponding angles, our alternate interior, alternate exterior angles, or our consecutive interior angles. Well, here we get alternate interior angles. So angle ADB is congruent to angle CBD. So that's alternate. Oh, I should probably spell that right. Alternate interior angles. So triangle ABD is congruent to C. DB, corresponding parts of congruent triangles are congruent. Three congruent angles, three congruent sides, congruent triangles, if we name it properly. So let's go through another exercise and see if we can't use the information and identify our congruent parts. So ABGH is congruent to CDEF. So we go 1, 2, 3, 4, 1, 2, 3. So angle A is congruent to angle C. Angle B is congruent to angle D because 1 with 1, 2 with 2. Angle G is congruent to angle E. And angle H is congruent to angle F. Let's list the corresponding sides. So AB with CD. Side AB is congruent to side CD. BG with DE. side BG is congruent to side DE. Then GH with EF. And last but not least, we've run out, so we're going to go first and last. So side AH is congruent to side CF. We've named all the corresponding parts. Now let's find the value of x. We have 4x plus 5 degrees. So we know this is h. And let me pick yet another color to highlight what goes together. We'll do gray. Not the best color, and we got h here, which is angle 4, so it's going to match up with f. So f is here, 105. So 4x plus 5, and it's also here because we already identified it, equals 105, because to solve for x we need an equal sign. Then we're just going to do some really simple algebra and solve for x. All right, so in the diagram, show that triangle PTS is congruent to triangle RTQ. So we need P to match R. We need angle T in this triangle to match angle T in this triangle. And then we need angle S to match angle S. So parallel lines. So angle P is congruent to angle R, alternate interior angles. Angle S is congruent to angle Q, also because of alternate interior angles, which we should be working hard at identifying immediately and looking for those specifically when we see parallel lines, because they do keep coming up on us for some odd reason. And then the last thing is angle P TS is congruent to angle RTQ because they're across the X from each other, so that makes them vertical angles from many, many lessons ago. We've got three sides, so we have triangle PTS is congruent to triangle RTQ. Corresponding parts of congruent triangles are congruent. All right, so quick refresher. If triangle MNP is congruent to QRS, MNP is congruent to QRS, then QRS is congruent to triangle MNP. What property is that? Pause the video, answer the question, and we'll see if you remember. Because you could look back at the beginning of this lesson to refresh your memory. It is the symmetric property. Good job. So the last thing we're going to talk about in this section is relevant to us because triangles only go together one way, and there's 180 degrees in any given triangle. So if we know two angles in a triangle, we actually know what the third angle is. So if two angles in one triangle are congruent to two angles of another triangle, which means the measures of those angles are the same, then the third angles also have to be congruent. So if angle A is congruent to angle D and angle B is congruent to angle E, then angle C is congruent to angle F. So let's think about why this might be true. So if the measure of angle B equals 70 degrees, and the measure of angle A equals 30 degrees, then 180 minus 100 means the measure of angle C equals 80 degrees. Well, if angle E and angle B are congruent, so the measure of angle E would then be 70 degrees. The measure of angle D would be 30 degrees. So 180 minus 100 is still 80 degrees. Because we have a fixed amount of degrees in the triangle, if we know 2, we know 3. And if 2 sets are congruent, that third one has to be congruent because they've got to be the same number. That's all that's left over. So let's use that to our advantage. So we want to find the measure of angle BDC, which is right here. And there's a number of ways we can do it. Let's look at this. Here we have a triangle that includes angle BDC. Okay. Well, 30 degrees for my 2 means this is 30 degrees over here. 45 degrees for 1 means A and B are the same, so this is 45 degrees. Well, angle BDC has 180 degrees in it. We used up 75 of it, so the measure of angle BDC equals 105 degrees. Or we could have said that triangle NDC is 180 degrees minus 60, so this is 120. Angle BND and angle DCN, or angle, DNC are a linear pair, so that has to be 60. 60 and 45 is 105. So this has to be 75. 75 plus 30 is 105. No matter how we slice it, our blue angle there, BDC, the measure is going to be 105 degrees. As long as we follow the rules, we're good to go. So now, our last example, let's find the measure of angle CDB, which is this one right here. Well, here's 52, so this is 52. We have 90 and 52, so 180 minus 90 minus 52 is going to be 140, 50, 38 degrees. The measure of angle CDB equals 38 degrees. And so then the measure of angle ABD is also going to be 38 degrees. And we are done.